Solve exponential functions. We will solve the following questions. For s to 2 times x minus 1 is equal to 3 to the power of x plus 5 to the power of x plus 3 is equal to 8 to the power of x minus 1 to the power of x plus 1 is equal to 0.5 to the power of x minus 2, and the other questions are solved in this part. Dear all, don't forget to subscribe, like, share these channels. Now let us start from questions number 1. Solve 2 to the power of x plus 3 is equals to 8 to the power of x minus 1. Now here we are to find the values of x. There. The domain of this function is which is real numbers. So we can solve like this. 2 to the power of x plus 3 is equals to 8 to the power of x minus 1. Now here the base of those exponential functions are different. Therefore, we should have to turn into the same bases. Now, since 8 can be expressed as the base of 2, that means 2 to the power of 3. So we have 2 to the power of x plus 3 is equals to 2 to the power of 3 times x minus 1, since 8 is 2 to the power of 3. Now, 2 to the power of x plus 3 is equals to 2 to the power of 3 times x minus 1, if and only if their exponents are equal. So, x plus 3 is equals to 3 times x minus 1. And this is equal with x plus 3 is equals to 3 times x minus 3, because 3 into x minus 1 is 3 times x minus 3. So x plus 3 is equal to 3x minus 3. That now, by rearranging this, or by writing variable by variable or constant to constant, and here this can be expressed as x minus 3x equals minus 3 minus 3. That means x minus 3 is minus 2x, and the minus 3 minus 3 is minus 6. Then we have minus 2x is equals to minus 6. And since minus 2 is different from 0, then we can divide both sides by minus 2, then minus 2. X over minus 2 is equals to minus 6 over minus 2, then we have x is equals to 7. So the solutions for this expression is x is equals to 7. You may check these expressions when if you substitute x by 3. For instance, if you substitute x is equals to the power of 3 plus 3, which is to the power of 6. To the power of 6 is 64. Again, if we substitute here the values of x is equal to 3, then 8 to the power of 3 minus 1. 8 to the power of 3 minus 1 is 2, then 8 to the power of 2, which is 64. Then 64 is equal to 64, therefore the solution is which is x is equal to 3 is correct. The other question, solve 2 to the power of x plus 1 is equal to 0.5 the power of x minus 2. Now, to solve these expressions, if it is possible, we should have to change, or we should have to write into the same base, and we can equate their exponent. And since the domain of this is also which is real numbers, and here we express this since 0.5 means 1 over 2, so we have 2 to the power of x plus 1 is equal to 1 over 2 to the power of x minus 2. Because 0.5 is equal with 1 over 2. Again, we know that 2 is equals to 2 to the power of minus 1 is equals to 1 over 2, or 1 over 2 means 2 to the power of minus 1. So we have 2 to the power of x plus 1 here is equals to 2 to the power of minus 1 times x minus 2. Here the bases are the same. If their bases are the same, then this is f, and only if their exponents are equal, that means x is equal, x plus 1 is equal to minus of x minus 2. And this is equal with x plus 1 is equal to, so this is by multiplying by minus 1, we have minus x plus 2. Again, this is the same as x plus x is equal to minus 1, then we have 2x is equal to 1. Then dividing both sides by 2, we have x is equals to 1 over 2. So the solutions for this expression is 1 over 2. You may check, or by substituting the values of x is equals to 1 over 2 here. And now let us proceed to another questions. 4 to the power of 2x minus 1 is equal to 3 to the power of x plus 5. Here the base are different. So how can we express this? Now we can solve this. So I told you that this is the domain for these expressions is which is all real numbers, because the domains for the exponential functions which is express y is equal to b to the power of x is a real number. So these expressions has a domain a real number. So here to solve this, let us we express by using a rule or properties of exponential functions. Now here 4 to the power of 2x minus 1 can be expressed as 4 to the power of 2x times 4 to the power of minus 1. Again, 3 to the power of x plus 3 is also expressed as 3 to the power of x times 3 to the power of 5. Again, this can be expressed as since 4 to the power of 2 times x is the same as 4 to the power of 2 to the power of x. This is using the rule for x to the power of m times in the out of the bracket n is the same as x to the power of m times n. So that means x to the power of m times n is the same as x to the power of m to the power of n or times n. So this 4 to the power of 2x times 4 to the power of minus 1 is equal to 3 to the power of x times 3 to the power of 5 can be expressed as 4 to the power of 2 to the power of x times 1 over 4, since 4 to the power of minus 1 is 1 over 4, is equal to 3 to the power of x times 243. 243 is, that means, which is 3 to the power of 5. So since 3 to the power of 5 is 243, and 4 to the power of minus 1 is 1 over 4, 4 to the power of 2x is 4 to the power of 2 times x. So we have 4 to the power of 2 to the power of x times 1 over 4 is equal to 3 to the power of x times 243. Again, this is equal with, or this can be expressed as here, since 4 to the power of 2 is 16. Then we have 16 to the power of x times 1 over 4, which is 16 to the power of x over 4 is equal to 3 to the power of x times 243. Again, here we can divide, since 3 to the power of x is different from 0, therefore we can divide here both sides by 3 to the power of x and multiply both sides by 4. Then we have 16 to the power of x over 3 to the power of x is equal to 4 times 243. Again, using the rule that x to the power of n over y to the power of n is the same as x over y to the power of n whenever y is different from 0. So it means here x over y to the power of n is equal with x to the power of n over y to the power of n, or x to the power of n over y to the power of n is the same as x over y to the whole n when y is different from 0. Then using this rule, this 16 to the power of x over 3 to the power of x can be expressed as like this: 16 over 3 to the power of x is equal to 972, because 4 times 243 is 972. So again, this can be expressed as y is equal to b to the power of x. So if y is equal to b to the power of x, then x can be changed by writing in logarithmic form. We can obtain simply the values of x, which is x is equal to b to the power of y. Like this: if y is equal to log of x by the by and only if this x equals to b to the power of y. So 16 over 3 the power of x is equal to 972, means x is equal to, which is log of 972 in base 16 over 3. So this is the values of x. Thanks for watching my video. Don't forget to subscribe. If you subscribe it, don't forget to like it. Thank you.